Warahmatullahi wabarakatuh, and a very good day. Today, I'm going to share with you how to analyze reinforced concrete column. At the end of this lesson, you should be able to determine the load on the column, determine the moment of column, and illustrate the moment of the column. So, for example, here I have a structure layout plan that has been prepared after we receive the architecture plan. So this is an example for structure layout plan of double-story bungalow house. I'm going to design column A5 here. So this column A5 is connected with two direction of beam here and also here. Okay. So, and it also connected with two slab here, panel 2 and also panel 3. So consider as panel 2 is a family area, panel 3 is a bedroom. Given the design specification for this structure, the variable Asian is 2.5 kilonewton per meter square, finishes is 0.25 kilonewton per meter square, shielding and services. Brick wall for the first floor is 3.3 meter high, and then brick wall for the ground floor 3 meter high. The slab thickness is 125 millimeter. The beam size is equal to 175 millimeter times 400 millimeter. Column size is 175 millimeter times 200 millimeter, and then the structural class is C30. So, first process, we have to draw the sectional view of column A5. So the sectional view we have to draw for both axis, X axis and also Z axis here. So for the X axis, this column is connected with two beam A35 and also A57 for each floor. And then for column Z, for the Z axis, it's connected to beam 5AB. Okay. So next we have to draw the load sectional view or action sectional view for each axis, X axis and also Z axis. So for the Z axis, X axis here, okay, for the roof floor there is load from the beam and also load from the roof. So for the first floor is load from the beam and also load from the slab 2. Here is load from the beam and also load from slab 3, and here is also the same. So for the Z axis, so at the roof floor there is a load from the beam and also load from the roof, and then here for the first floor load from the beam and also load from the slab 2 and also slab 3, same as ground floor. So next we have to analyze of action on roof. So let's say I have this roof layout plan. Okay, so the roof tile will transfer the load from this section to this section to this section. I only have 2 support here. Okay, so you may have a 3 support if you would like to have. Okay, so it depends. So in my case, I will only have 2 support here. So they will transfer the load from here to here and also from here to here. So what are the elements that will contribute the load on top of your roof? The first one for the permanentation is truss, roof tile, purlin, shielding and services, batten and felt, and insulation. So you may add additional one. So if you have a water tank on top of your roof, so you have to calculate also the load from your water tank. Okay, so the total QK is 0.26 kilonewton per meter squared, is based on the Eurocode suggestion or recommendation. So the action transfer from roof to the beam, we using a one-way slab formula and LX over 2. So 2.17, okay, times 4.91 for the permanent action. Okay, 4.91 is the length, okay, divided by 2. And then for the variable Asian is also same, NLX over 2, 0.26 here times 4.91 divided by 2. So you will get the answer 0.64. So no need for you to factorize it first. Okay, we have to separate also between the permanent action and also variable action, because we have to get the total permanent action and variable action for the element that will for each of the element from slab, beam, and also column, because we going to use that value in order to design foundation. Okay. Next process is analysis action on slab. So the analysis action on slab here, so I'm going to analyze panel 2 and also panel 3. The first one, we have to determine the condition of the slab, either it is a one-way or two-way slab. In my case here, panel 2 and panel 3 here is a two-way slab. So another thing is we have to draw this load transfer line. So in order for us to know the load that will transfer to the beam, either it is trapezoidal or triangular load. So in my case here, panel 2, so for the beam 3, 5 here, it will receive a load from this panel 2 with triangular load. So for beam 5, 7, it will receive a load from panel 3 with a trapezoidal, and so on. Okay, so next process, we have to calculate the action on the slab for the first floor and also ground floor. I assume there is no slab on top of your roof. So for the first floor here, the permanent action is contributed by slab self-weight, finishes, and also shielding and services, and also the variable action here is 2.5. Okay, the slab self-weight is equal to 25 times with the thickness of the slab. So for the ground floor, the permanent action that is contribute, the permanent action on top of the slab of ground floor is only slab self-weight and also finishes. There is no shielding and services for the ground floor. Okay, so next process. So I do already summarize the action transfer from slab to the beam A35 and beam A57 in this particular table. So in my case here, so I have this is for x-axis. I will do the same process for z-axis. Okay, so this is a beam A35, this is beam A57. We transfer the load from the slab to this beam, the load from this slab to this beam. Okay, so I do already told you that for the first floor, okay, for the beam 3-5, the load that will receive from this beam is load from the slab 2 with a triangular shape. So I'm using this formula NLX over 3. So your N here is taken from this load. Okay, so from this load, which is 3.625, the total QK is 2.5. Okay, for the slab 3 is 3.375 for the ground floor. Okay, and 2.5 for the QK. So here is for the first floor, here for the ground floor. Okay, so how to get this 3.383 for the permanent action is equal to N 3.625, okay, for the first floor, okay, time with your LX here. LX is 2.8 divided by 3, you will get 3.383. For this variable action is equal to N is equal to 2.5 times 2.8 with your, which is your LX, divided by 3, you will get 2.333. So for the beam A57, the load that this beam receives is from slab 3, okay, with a trapezoidal load. So therefore, we will use this formula. So the N here for the permanent action is 3.625 times with your LX here 3.025 divided by 6 times 3 minus LX is 3.025 divided by LY 3.325 power of 2. You will get this answer. Then you repeat the same again for the variable action with N equal to 2.5. Okay, for the ground floor here, so the difference is only the permanent action that you're going to use, which is, okay, which is 3.375 for the permanent action, then variable action is 2.5. Okay, So you change the value here for your n, okay, and then you will get this answer. Next, we have to do the same process also for the action transfer from slab to the beam 5AB. So for beam 5AB for the ZZ axis, okay, for the first floor, it will receive a load from slab 3 and also slab 2. So the load from slab 3 is in triangular shape. Load from slab 2 will be trapezoidal shape. Okay, so you will get the answer for the permanent action and also variable action by using this formula. Depend on the load condition, with either it is triangular or trapezoidal. Okay, so you will repeat the same calculation again for the ground floor. Next is analysis load on the beam. So for the analysis load on the beam, so we have to calculate action on the beam for the roof floor, first floor, and also ground floor. Sorry, this is a typo. Okay, so what are the elements that will contribute load or action on beam for each floor? So for the roof floor, there is only beam self-weight. There is no variable action for the beam because the variable action is calculated on top of your slab. Okay, for the first floor is equal to beam self-weight and also brick wall with 3.3 meter height. For the first floor, beam and also brick wall for 3 meter height. So you will get the answer here. Okay, next we calculate the load here. Okay, so there is no variable action. There is a load that we transfer, okay, that we have as a uniformly distributed load in kilonewton per meter, okay, on top of your beam here for both axes. Okay, so this one for ZZ axis. Okay, next is the total factored action on a beam. Okay, so here is the load. Okay, we have to calculate the total action on the beam for the both axes, XX and also ZZ axis. So for the roof floor, there is a load, okay, from the beam A35 and also roof. Okay, for the first floor, there is a load from the beam from and also from the slab 2. Okay, for beam 35. For the ground floor, there is a load from the beam and also slab 2. For the beam 57, okay, here, okay, there is a load at the roof floor from beam and also roof. For the first floor, beam and also slab S3 and same as a ground floor. So the value here that you get okay, you total up the value here, okay, you total up the value here for the permanent action and also variable action here, okay, then for the all the beam, okay, all the beam, and then you time up with the factor 1.35 GK, which is 1.35 GK times 7.08 plus 1.5 times 0.65, you will get 10.52. So for these cases, 1.35 times 13.713 plus 1.5 times 2.333, you will get 22.01. So here 1.35 times 12.7 plus 1.5 times 2.33, you will get 20.64. So you repeat the same calculation for all of the beam. You have to do the same process for the ZZ axis here. Okay. Okay, next is the frame analysis of the column. So what is the frame analysis of the column? The frame analysis of the column, in order for us to know, okay, the bending moment that is acting on top of the column that we're going to design. Okay, Next, we have to do is we have to calculate the load on column for both axis XX and also YY. So why we have to calculate load on the column or action on the column? It is for the purpose to determine the axial load and acting on top of this column in order for us to design this column, because we need that NED value. So for the XX axis, okay, we have to total up for each floor for x-axis and also z-z axis. So we have to calculate one by one x-axis axis and also z-z axis here. So here I do already separate for the unfactored load, okay, on top of this beam, okay, for each floor, roof, first and also ground floor. For the roof floor, we have a beam B A53, beam A57, and column from first floor to roof floor. Okay, for the first floor, beam A53, A57, and also column ground floor to first floor. And we have ground floor for the beam A53, beam A57, and column F2, foundation to ground floor here. Okay, so this is the unfactored load. So how I calculate this factored load? Okay, so the first one, we have to go for beam A53, which is 2.8 meter length. So the permanent action here is equal to, okay, because the unfactored load is in kilonewton per meter, so we have to calculate the reaction here in kilonewton. So reaction here is WL over 2. So it's equal to 1.35, which is the factored for permanent action, time with 7.08, okay, which is your W, and then time with your L here for length 35, okay, 2.8, which is then divided by 2, okay, you will get 13.38. Okay, for the variable action here is 1.5, which is affected for variable action, time with 0.65, okay, time with 2.8 length divided by 2, you will get 1.34. So for beam A57, okay, is equal to 1.35, okay, time with 7.08, time with the length 3.325 divided by 2, you will get this answer. And then for the variable action here is equal to 1.5 times 2 times 0.64 times with 3.325 divided by 2, you will get this answer. Okay, and then we have another load here, which is, okay, a load from this column. Okay, so the surface of this column is 25 times with a column size, which is 0.175 times with 0.2, if I'm not mistaken. Okay, so you may refer to the design specification, then you will get here. And then to get this 3.92, you have to time up with the height. Okay, then we have to add up the total permanent action here, the 13.38 plus 15.88 plus 3.92, we get 33.18 here. And then for the variable action, 1.34 plus 1.6 is equal to 2.94. And then the total axial load for the roof floor is 36.12, 33.18 plus 2.94. Okay, so for the first floor here, okay, we get this value, okay, from the previous table. Okay, from the previous table, 13.71. Okay, here 13.71, 2.33, and 14.3, 2.738. Okay, so this is the surface of the column. Okay, so how to calculate this factor? Okay, same as what we have done here. Okay, and then the ground floor, the first floor here is 2.64 because of 0.88, okay, time with 1.35, okay, time with the column height. The column height here is 3 meter. So that's why you get 2.64 2.64. Okay, and then here is the accumulative, okay, from this roof law 33.18 and 2.94. You have to carry forward because the axial load here, okay, will be accumulative from this floor and also this floor. So the total for the permanent action here, okay, is total up of this load. Okay, so you will get 93.82, and then for the variable action is 14.66, and then you total up 108.48. The same process here you have to do for the ground floor. So you have to carry forward the total load from this floor, okay, 93.82 and 14.66 to here, and then you will get the total up here, okay, which is 148.88, and also for the variable action is 26.38, equal to 175.26, which is the axial load, okay, for the ground floor that we are going to use in order for us to design the foundation. We have to do for the zigzag axis a same process, okay, a same process. So the total load, okay, for the zigzag axis at roof floor is 6.69. For the first floor, 53.34. Okay, for the ground floor is 99.10. Here, okay, is the load diagram. Okay, so the load diagram, we have to calculate it, okay, in order for us to know the bending moment for the column. Also, okay, stiffness of the beam and also the column. From the so here are the diagram showing the load that is acting on top of the beam. So we have to calculate the fixed end moment and also stiffness of the beam and also column for both sides. Okay, so here is how to calculate it. The first one is the fixed end moment for the roof floor, first floor, and also ground floor. The fixed end moment for beam 3.5 and also 5.7. Okay, so here the load. So the formula is WL squared over 12. So you will get the fixed end moment for beam 3.5 equal to 6.87, 5.7, 9.69. So you have to calculate for the rest of 6 beam. Okay, next is calculating the stiffness. So we know that, okay, stiffness is equal to K is equal to EI over L. Okay, in order for us to calculate it, so we have to calculate I, the moment of inertia. So for x-axis, so the way we have to calculate is BH cubed over 12. While for the z-axis, is supposed to be HB cubed over 12. Okay, because the major axis and also the minor axis is already different. Okay, so you have to calculate here. Okay, so in order for you to calculate the stiffness for the column or for the beam here, so EI over L is equal to, okay, your I over L. The L length is 2.8 meter. Okay, and then divided by 2 because we transfer half to this column and another half to this column. The same process we have to do for the rest of the beam. Okay, here is the stiffness of the column. So stiffness of the column is equal to I of the column, BH cubed over 12. Okay, BH cubed over 12 divided by L, which is length of the column. Okay, so for the lower column and also for the upper column, so you have to calculate it differently. Okay, so here you have to be careful. Okay, the I here that you have to use, okay, is reflect to the I for the column. Okay, so you have to make sure that the I for the column that you use is correct. So due to the z-axis and also due to the x-axis. Okay, so you have to total up all those stiffness. Okay, next we have to do for another axis, which is for zigzag axis. Same process, we have to calculate the fixed end moment, and then we have to calculate the stiffness, and also we have to calculate the EI. Okay. Next, we have to calculate the balance moment at the column XX axis and also ZZ axis or YY axis. Okay, so we have to go through one by one for the roof first and also ground. So here are the fixed end moment clockwise, which is positive, anti-clockwise negative. Okay, so here is the balance moment is equal to 6.87 minus 9.89, you will get negative 3. So same goes to the rest one. You have to calculate the same one. Okay, and then this is the K of the lower column and K for the upper column that you have calculated before. And then this is the summation. And then for the moment of the lower column is equal to M, which is negative 3, time with the K of the lower column 3.5 divided by summation of K, which is 7.34, you will get this answer. So for the upper column is equal to 0, and then you go for the first floor. Okay, M is equal to negative 7.919 time with the K of the lower column, okay, which is 3.89, okay, divided by 11.23, you will get this answer. And then K for the upper column here is M is equal to negative 7.19 time with the K of the upper column 3.5, okay, because when it is lower here, it become an upper column here. Okay, so divided by summation of K, which is 11.23, you will get negative 2.24. So you have to do the same process for both axis, x-axis and also z-z axis in order for you to get this moment. Okay, so next process, so you have to draw the bending moment of the column. So here is the moment of the column. Okay, so here for the roof floor, here for the first floor, here for the ground floor. You take the maximum one between the ZZ axis and also YY axis. So here will be your ZZ axis, here will be your X axis, which is the longer here is become your primary, here will be your secondary. Okay, so your N here is equal to 36.12 plus 6.69. This is the total action or the N that you calculate previously, okay, from the X axis and also Y or Z axis. So I will show you here. Here is the value 36.12 from Z axis, from X axis, sorry. And then here from Z axis 6.69. Okay, so that's why you get the total value of your N here is 42.81. So same as the rest one. Okay, same for this one. So here 265.36 kilonewton is the load that you are going to use in order for you to design your foundation. Okay, so I hope that by this explanation you understand how to analyze the column. Then you may proceed after you get this moment value and also the point load value or the axial load value, you may proceed to design your column. Okay, so as usual, you have to do your classification check and also you have to design your column, either short or slender column. I hope that this explanation will help you to analyze the column, and if you have any question, you may comment or you may ask me. Okay, so thank you. Assalamualaikum.